Today, I'd like to talk to you about shapes and relative positions. So this will take you back to your time in primary school or secondary school probably, when you learned the names of different shapes in your own native language. And I'll also talk a little bit more about how to precisely describe the position of one object relative to a second object using prepositions. Now, I'll upload a sheet which has two columns in it. So a list of the nouns which refer to these particular shapes and the adjectives. And there's also a series of little sketches which show the individual shapes. Then for the relative positions, there's a list of the prepositions or expressions, and to the left of those, some sketches which show the relative position of one object in comparison to the other. I'll begin by showing you a few engineering components. If you take, for example, this large hexagon nut, so this I believe was something from some hydraulic equipment for testing structures, and maybe for breaking pieces of concrete to see how strong they are. It's quite large. In the center here, you can see that this hole is a circle, and that's the noun for this shape, circle. The adjective is then circular. If you look at the outer edge here, it has 6 sides, and all of the angles are equal. All of the angles are 60 degrees. So this is a regular hexagon, and the noun is hexagon, and the adjective is hexagonal. Inside here, you can see that there's a screw thread. Now, the shape of the screw thread is a helix. It's like the helix in DNA, for example. And the difference between a helix and a spiral is that the diameter of a helix is constant, so like the screw thread. A spiral is a similar shape, so it takes this kind of form, a winding form. But as you go along the spiral, the diameter increases or decreases. That's what you would see, say, in a snail shell. And if we take a look at a few others here, this one here is the chuck from a drilling machine. And you can see this part here, the diameter changes as you go along the length. It's not something which has a certain path or groove to it. It's merely the fact that the diameter changes, and this is something that would be described as a taper. You can also see an interesting feature in this chuck. You can see here that the surface has been roughened, so the steel here has then been embedded with a series of grooves by spinning it between 3 wheels that press hard against it. And this surface is known as a knurled surface, so Knurled. In the end, you can see here that there are 3 jaws, which are designed to grip the drill. Now, if the drill has a circular cross-section, you would not normally describe the drill as being circular. To an engineer in England, that would sound strange. The same goes for steel that you might buy for a project. So steel stock, you would not describe it as being circular steel. When it refers to a cross-section, you'd normally use the word round. Now, in that case, English isn't very consistent. The noun is round, and the adjective is also round. If you talked, instead of talking about a round bar, if you talked about a circular bar, you'd think of something more like this. This here is a ring, so in cross-section it's round, but the path it takes is circular. And when the diameter of the bar is very small here, and then you think of it as being a ring, if this gets very fat, so the hole in the center gets smaller, you'd think of it as being a torus. Sometimes that's also described as being a toroid, the two are the same, and the adjective follows the same pattern as it does with the hexagon, so it's toroidal. This shape here, the brass, this is a crescent, so it looks a bit like a crescent moon, and this here is actually known as a moon scale. It's a very old scale from about 1890 or 1900, designed for weighing sacks on a farm. This shape here, of course, is a hook. If you take a hook and you close both ends of it, so you can no longer hook a sack over it, it's something that won't come off, and the other point it's attached to, and then that would be like the smaller part here at the top, that would be an eye. I'll go back to a few simpler ones now. This cover plate here is a rectangle. Now a rectangle is like a square, except that it has two different side lengths. You see at the top and bottom it has two short sides, and to the left and right it has two longer sides. All of the corners are still right angles. That's a rectangle. The adjective is rectangular. If all of the angles and all of the four sides are equal, it's then a square, and the adjective is also square, so the same as the noun. This is a flexible coupling, so it's designed to connect an electric motor to a load, which may not be perfectly aligned. So it may be that the shafts are at a slight angle, or they're slightly offset from each other. And if you didn't have a flexible coupling, something that can change shape slightly, then it would cause very high stresses in the shaft. Of course, because the shaft is rotating, these stresses would then, at one point in time, be tensile, and shortly afterwards they would then be the opposite. They would be compressive. And so the material would be pulled and pushed and pulled and pushed and pulled and pushed. And this causes fatigue. So small cracks that develop in the motor shaft, it wouldn't last very long. It would quickly break. So here you have a flexible shaft coupling. And what you can see here on the surface, you can see grooves that go around the whole of the circumference. And the difference between a groove and a notch is the axial length. So here with a groove, the axial length is very long compared to the width of the groove. And with a notch, it would be something where the axial length was probably less than the width of the notch, or equal to the width of the notch. These parts are actually made out of thin, springy stainless steel sheet. They're actually called bellows. For a moment, I'll just go back to this cover plate here to give you another interesting word here. You can see how these slots have a little cover over the top of them that's sloping downwards so that water can't fall inside. That's called a louvre, L-O-U-V-R-E. That comes from the French, and it's so that you can provide air circulation without allowing water to fall inside. The shape I described here, by the way, the bellows, that's spelled B-E-L-L-O-W-S. Here's a funnel. Now, a funnel is used to pour a liquid into a small hole that you would probably otherwise miss and spill the liquid on the floor. The reason I'm showing this to you is because on the outside here, it feels like it's rounded and it protrudes, it sticks out, and that's convex. The adjective for describing the inside surface here, where it feels more bowl-shaped, like it dips in, that's concave. And it's important to see here that convex and concave depend on the location of the observer. One last thing I'll show you. This is a clutch withdrawal fork for a car. You can see that the English just follows the basic shape of it. It's like a branch forks, or a road forks, or you have a fork for a barbecue or something where the handle divides into 2 or 3 or 4. One of these fingers goes down on either side of the shaft and pulls on a collar, which is basically a specially shaped ring that goes around the shaft. And this collar is then attached to one of the clutch plates. It pulls it back against the spring and then separates the clutch plates and disconnects the drive from the engine to the wheels. Now, to talk about relative positions, I have a large glass here and a Christmas apple. Prepositions are something that people get wrong a great deal in technical English, and it's something you really need to work on because they may not be the same prepositions that you would use, the direct translations of the ones that would be used in German. And if you use the wrong preposition, it would be very confusing for the reader. So here you can see that the apple is in the glass. Here you can see that it's outside the glass. Here, the apple is in front of the glass. And here, behind the glass. There are a few interesting exceptions here, peculiarities in the English language. The opposite of inside is outside. That's fairly straightforward. But the opposite of within, which is a synonym for inside, is without. Now, you'd normally think of without as not having something. You know, I came to work without my car. But in older-fashioned English, you might read a sentence like, the soldiers stood without the city walls. That means that the soldiers stood outside the city walls. You'll still come across this in some technical English, especially if you read patents and legal documents. Another interesting one is, instead of writing in front of the glass, you can say before the glass. Now, before can have a meaning in terms of time. It can also have a meaning in terms of position. Behind, however, is a little simpler. Here you would say that the apple is sitting on the edge of the glass. The on then suggests that some support is involved, like the edge of the glass is supporting the apple. Here I'd say that it's beside the glass or next to the glass. You could be more precise here and say that it's touching the glass. Be a little careful if you use the preposition at, because at normally goes together with one specific point. It would be better here to use the preposition at to say at the center of the glass. And here you can say either it's at the center of the glass's volume, or you could say it's at the center of the bottom of the glass. That gives you a little introduction to the prepositions which are used to describe relative positions. The rest are on the sheet, which I will upload to StudIP when I upload this video. What I want you to do for your assignment this week is to take a look at the picture of the truss bridge, which I will also upload. This is a picture of a bridge on an American freight railway, I think in the 1970s, and it's basically a beam bridge. So you understand what a beam is. A beam is a thick member which is loaded in bending, and to strengthen this beam, it's then had a framework of triangles built on top of it, which provide some stiffening. And triangles are a good shape because when you have 3 side lengths, they can only exist in one configuration. Unlike, say, 4 side lengths where you could have a square, or you could then have 2 smaller angles and 2 larger angles, and it then becomes a diamond, which is also known as a rhombus. Now, with the word diamond, the noun is diamond, but for the adjective you would have to use diamond-shaped. For the rhombus, the noun is rhombus, and for the adjective you'd say rhomboidal. When you look at this picture of the truss bridge, it's also worth thinking about which members are in bending, which members are in tension, and which members are in compression. Because normally to carry a load in bending, a member needs to be very thick. To carry a load in tension, it can be very thin. And to carry a load in compression, it needs to be somewhere in between the two. And you can see this in the frame of this scroll saw here. This is the blade here, which is in tension. And this frame here is loaded in bending. So this is squeezed together, and then the blade is then tightened into the frame, and then it's released, so that the bending in the spring steel frame then tensions the blade. And you can see the difference here. This blade is very, very small. It's only about 1 millimeter thick. This frame that goes around the outside is probably about 8 millimeters thick, something like that. So you can see the ends of the spectrum, very thin when you load something in tension, very thick when you load something in bending, and somewhere in the middle for compression, all to carry the same kind of force. What I want you to do is to look at the picture of the truss bridge and write a short text, something of 100 to 200 words, describing how the bridge is built. So what types of members it has, how thick they are, how they're arranged relative to each other, what shapes they make up. And think about my top 10 tips that I gave you in the last session, and try to start the text particularly in a sensible way. So you say what the purpose of the bridge is, you have a good introductory sentence and a good closing sentence at the end. So that's your assignment for this week. Use the material from the sheets on the shapes and relative positions to describe the truss bridge using the photo that I'll upload. It should be approximately 100 to 200 words long, and it's due on the 18th of May. You should then send me the finished text by email as a PDF. If you want to include a picture of the bridge, you're welcome to do so. If you've got any questions, please let me know. That's all for today. Thank you.